This is Dr. Jack Jackson, and this is the fourth in our series of lectures on descriptive statistics. This particular one will be on measures of central tendency. Measures of central tendency are numbers that try to describe the center, middle, average, or typical data value with a single number. So this statistic is an interpretation of what central means, and it's different for each of the different types of measures that we will use. These are the ones that we're going to be looking at today: median, mid-range, mid-quartile, mode, and mean, or arithmetic mean. Each of these gives a different meaning of average, middle, central, or typical data value. The idea in all of these, though, is to take a data set and replace it with one single number that gives you some idea about where the middle of that data set is. So obviously you're losing lots of information, but it does give you some information about that data set in a single number. Let's start with the median, which we've already looked at earlier, because the median is a measure of relative standing and it's a measure of central tendency. We defined the median and talked about how to interpret it back in the lecture on measures of relative standing. Just recall that 1/2 of the data is below the median. Of course, 1/2 would be above it. So it splits the data into two equal halves. So in that sense, it is the center. This is probably the second most often used measure of central tendency, the mean being the most often used. It's not affected by outliers. So if we have a data set and we take the maximum in that data set and move it much larger, could be very, very, very large, it has no effect on the median whatsoever. In fact, if we move things around within the data set, it's only when we move one across the old median that we change something to be a new median. Recall that if the data value, if the sample size is odd, the median is one of the data values. It's the middle one in a ranked list or an ordered list. When n is even, you have a tie for the two in the middle. You average them, so it may or may not be a data value when n is even. Let's contrast that with another measure called the mid-range. The mid-range is halfway between the minimum and maximum. So it's the same distance from the minimum to the mid-range and also from the mid-range on up to the maximum. To find that, you just simply average the minimum and maximum. That is, you take minimum plus maximum, take that number to divide by 2 to find the mid-range. It is used less often than the mean, median, and the mode, which are by far the three most often used measures of central tendency. Probably in that order. If we compare and contrast median and mid-range, we see that the mid-range is the same distance from the minimum and the maximum, but there may be different amounts of data above and below it, whereas the median might be closer to the minimum or possibly closer to the maximum, but it has the same amount of data above and below it. Of course, it is possible in some data sets that the median and the mid-range could both be the same thing, but they don't have to be. For example, let's take a look at this dot plot of the ages of inauguration of U.S. presidents at their first inauguration. This is the same data set we've looked at several times in these lectures. Remember that there are 43 different presidents, and we have their ages represented in this dot plot. Notice that we have the median of 54 marked on here, which we've seen before, and the mid-range of 55.5. We compute that by taking the minimum of 42, add the maximum of 69, add those up, divide by 2, and we get 55.5. And so you can see where that's marked here on the graph. So take the mid-range. Notice that it is the same distance, a distance of 13.5, in this case it would be years, from the mid-range to the maximum. So from 55.5 years to 69 years, that's a distance of 13.5 on our graph, or a difference of 13.5 years. It's the same distance from the minimum of 42 up to the mid-range of 55.5. However, notice that there is more data below that value than there is above it. 25 of the data values are below the mid-range, whereas only 18 of the data values are above. So the mid-range is the middle in the sense that it's the same distance from the bottom to the top, from the minimum to the maximum, but not necessarily in terms of the distribution of data. The median, on the other hand, is the middle in the sense of the distribution of data. There are equal amounts of data above and below the median. In this case, 21 values are below the median and 21 values are above the median. But the median is closer to the minimum. From 42 to 54 is a distance of only 12 years here. And from 54 up to 69, rather, is a distance of 15 years. So notice the median is closer to the minimum in this particular example. In other examples, it might be the same as the mid-range, or it might be closer to the maximum. In this example, it's closer to the minimum, even though the data values, 21 below and 21 above, those are the same. Just like we found the mid-range by averaging the minimum and maximum, halfway between the minimum and the maximum, we can also find the mid-quartile as halfway between the lower and upper quartiles. So it will be the same distance from Q1 and Q3. So to find the mid-quartile, take Q1 plus Q3, take that value, divide by 2. This one is also pretty rarely used. The mode is another one that's also occurs very often, or it's also used very often, and what it actually is the single most often occurring data value. So if you're looking at a data and you have one value that appears more than any other, that value is the mode. So what do you do if there's a tie? Well, there's actually a difference of opinion about this. If there's a two-way tie for the most often occurring data value, some people will say that the mode does not exist. They're very purist and they say that a mode must be the single most often occurring value, and that's it. If there's not a clear winner for the single most often, there is no mode. Others are okay with a tie, and they'll call both of these things modes, and they say the data is bimodal. We'll go ahead and use this if there's a two-way tie for this class. If you have three or more tied for the most often occurring data value, again, most people here will say the mode does not exist. Of course, you could talk about a data being trimodal or quadrimodal or something, but most of the time, if there's at least three or more that have the same highest number of occurrences, then we'll say the mode does not exist. So for this class, if there's a single most often data value, that's definitely the mode. If you have a two-way tie for the single most often, we'll call that bimodal and call them both modes. And if there's three or more tied for the highest, then we'll say the mode does not even exist. So notice the mode does not always exist, but it must be an actual data value if it does exist. It may be very far from the other measures of central tendency. For example, it could be an extreme value. It could be the highest one, the lowest one, or any one in between. What it is the one that occurs the most often. It's not really affected by outliers. So unless the mode is one of the extreme values, moving one of the extreme values is not going to affect the mode. And since it could be very much near one end or the other, I think it's probably more accurate to call this a measure of typical than middle, but we still classify this as a measure of central tendency. So back to our inauguration data, you can clearly see from the dot plot that 54 is the mode. In fact, one of the advantages of a dot plot is it is pretty easy to see the mode. It's clearly the highest one, with 5 presidents being inaugurated for their first term at the age of 54. It happened in this case that was the same as the median. It's not too far off of the mid-range, but these could have been considerably different. By far, the most often used measure of central tendency is the arithmetic mean, or we'll usually just call it the mean. It's often the one people mean when they say average. Although some people use the word average for all these measures of central tendency, if you talk about the average, usually you're talking about the mean. What do? You guys probably already know how to do this. We just simply add up all the data values and divide by the number of data values. If it's a population mean, we call this mu, the Greek letter mu. That's a lowercase mu there. And if it is a sample mean, we call it x bar. If we're measuring the x's of the data values, then their average is found by putting a bar over it, and that would be for a sample. Notice the formula is the same. Do not let this formula intimidate you. There's nothing to it really. It's just a shorthand notation. So when you see this big capital Greek letter sigma right here, or down here in this other formula, that is like a Greek letter S, like a Roman S. That's sort of the Greek version, and it stands for sum. S for sum, sigma for sum. So sum, of course, is another word for adding things up. So what are we doing? We're summing up all the x's. X sub k is from k equals 1 to n. So what is an x sub k? Well, the first data point you have would be x sub 1, and the second data would be x sub 2, and the third would be x sub 3. So for example, when we're looking at the inauguration age data, George Washington's age at his inauguration would be x sub 1, and John Adams and the age at his first inauguration would be x sub 2, and then x sub 3 would be for Thomas Jefferson, and so forth. Okay, and then n is the size of the population. So this says add all of them up from 1 all the way up to n. Or if we think of this as a sample, considering that we will have more presidents in the future, with this, if you just look at the first 43, that could think of that as a sample. Then little n is 43 because at this point, up through Barack Obama, we have had 43 different presidents. So n would be 43, and x sub n would be President Obama's age at his inauguration. So this just says add them all up. Add up all the ages and divide by how many you have. So we're adding up the ages of all the presidents, for example, in our example data, and then divide by how many presidents there are, in this case 43. That will give you x bar, the sample mean, or the average. How do we interpret it? Well, one way to interpret it is the equal share value. If we were to keep the total the same, the numerator that we just looked at, this summing them up is the total, but spread it out evenly so that everybody was the same, we will get the mean. So think back to our data from candy sales. We have a situation where we are selling candy and different people sell different amounts. Well, what if we had the total amount of candy, boxes of candy, the same, but we spread it out evenly so that everyone sold the same amount, so the equal share value? Well, then the amount each would sell would be the mean. When you divide by something, you're dividing into equal sized groups, so if we take the total amount, divide it out in equal sized groups, we'll spread it out evenly. Another way to interpret it physically is, like on a dot plot, it's the balance point or center of gravity. We'll see a little bit later on, particularly when we get to our variability section, that the sum of the deviations from the mean is 0. More about that a little bit later. It is affected by every single data value. So if you move one data value a little bit, it may have a perhaps small, but some effect on the mean. So it really does take into account the actual values of every single data value. Now, this can be extremely sensitive to outliers. Now, by what we mean by that is if you took a data set and you throw in an outlier, or you took, say, the minimum and moved it way low, that could really pull the mean down considerably, even though we're only changing one data point. So notice that the median, in contrast, was not affected by the outliers, nor was the mode for that matter, but the mean is. Once again, although all measures of central tendency are sometimes called averages, when someone refers to the average, they're going to be talking about the mean. This is the most often used measure of central tendency, but not always the best one. We have these different measures of central tendency, and so one of the things that we want to do sometimes is try to decide which one is the best one to use in a certain situation. So back to our inauguration age data, we see here the median is right here at 54.628, to at least round it off to 3 decimal places. And so if we were to place that arrow below this dot plot and think of this as a line that had no weight of its own, but the weights are given by the dots, that would be a perfect balance. And remember that just like if you're riding on a seesaw or teeter-totter or whatever you want to call that, a lever, if you're way out further away, then that's going to have more tendency to make the seesaw move up or down, okay, as opposed to somebody that is very close in. And of course, the more weight or the more dots you have at a certain place, that's going to affect it as well. So the mean is the balance point for this. So notice in this particular data set, the mode and the median were both 54, the mid-range was 55.5, the mean was 54.628. So we see that the mean, median, mode, and mid-range were all fairly close to each other. But in some data sets, they can be considerably far apart.